Okay, following on from the example I just did, which was question 1, I'm just going to also do question 5. So here we've got y equals x minus 2, x minus 5. So this will be a cubic equation with y-intercepts at 0, at 2 and at 5. So do a quick sketch of that. It's going to be, I've got to have x times x times x, which gives me a positive x cubed, so it's going to be this kind of shape. So there and there. So 0, 2 and 5. Now this is exactly the sort of example I spoke about above, where I've got part of my curve above the x-axis and part of my curve below. So this finite region there will be positive when I find the integral. So this will have a positive integral. This one will have a negative integral, which means I basically so this would be the same function there. So I'm going to integrate, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and here I'm actually not going to bother with my constant of integration because I know it's going to cancel out when I do the substitutions. This is from 0 to 5. Okay, so now I'll do all the substitution. First I put in 2, so I get 2 to the power 4 over 4 minus 7 times 2 cubed over 3 plus 10 times 2. Then I subtract what I get when I substitute in 0, which is going to be 0, 0, 0, 0, so I won't bother with that. Now I subtract. First of all, I put in 5, and now I'm going to subtract what I get when I put in 2. But I'm already subtracting the whole thing, so I'm actually going to be adding that on. And rather than writing out again, because this matches what I've already done here, I'm just going to say, right, I need 2 of those. So if that's confused you, you can just go and put in the whole thing. But if that makes sense to you, it's a little way that you can save time. I'll probably just pop that into my calculator actually, rather than do that in my head, and out will pop the answer for the total area. Ta-da! Just do it on my calculator and I get 1153 over 12, which I hope is correct.